that are up on top, the observed values, are the ones that were observed in our sample, okay? Now question, before we go any further, how do I figure out what the expected values would be in this context?
You use your sample size 2 times the probability.
Correct. So don't we take our probability, right? So we'll just call, for instance, if that was our probability that was stated, we take the probability that was up here, right? And what we would do is we would multiply that by my sample size, right? So 0.13 would be multiplied by, is there 50 here? Cool. So we say n equals 50. We'd multiply it to get what our expected would be, correct? Okay? How do I get the chi-square value again?
You have to take some expected squared.
Yeah.
Good. So the sum of the observed minus the expected squared divided by my expected. Cool?
Yeah.
All right. So real quick, I'm going to give you a quick shortcut of how you could help with this, okay? You don't have to do all of this by hand, though on the FRQ you'll see you have to at least do one of them, but you can actually go to your calculator here, and when you go to stat, test, okay, what do you think you'd go down to? Yeah, the chi-square GOF test. You'll see why in a second, why we use that. But if you go there, you're going to put your observed list into L1, which is the top part. And then once you find your expected, you're going to put that into L2. And how many categories did we have?
6.
Was it 6? So we would put degrees of freedom as 5, right? Okay? Here's what I would like for you to do as best as you know how. I want you to start at number 1, and I want you to go down in your groups to number 4 and even 5 as best as you know how. If there's parts you get like hit on, that's okay. But I'm going to give you about 5 minutes or so, and then 5 to 10 minutes, and then we'll come together on that, okay? Cool? All right, let's get it going. Max out podcasting for you, cool? All right. All right, go right ahead. We'll do the expected. We'll go from there. Let's do it.
Oh really? I took it back early. Yeah.
I got a big bag, so I was like,
Did y'all want one?
I'm good, thank you.
No thanks.
Oh, I'll take one. Oh, let's call my name right here. Oh yeah.
Good choice, sir. Good choice. I didn't even think though that I had y'all eat M&Ms early in the morning.
Yeah, were we supposed to eat those? We kind of just ate them.
I was a little offended you did.
Yeah? Okay.
No, I'm good.
If this is 2 pigs, I'm gonna get it instead. Oh, of course it's not 2 pigs.
Right, you're
Oh,
Of course. Alright. So all we're doing is, so he gave us these, and then we're finding our expected values based off the percent. So we're saying, so the total's 50, so you just multiply it to find like those, and then so you find this, you have the formula of the observed minus expected over expected. Then you add them all together to get that, and then.
you get how you found your expected?
I didn't
Alright, I'm going to give you about 5 more minutes. About 106 and 107 will come together on it.
Use table C to find what you want to see. Okay, do this first. Okay.
You ever want to get a formula sheet by chance? You might not. You're not. You want another one?
Why not?
This is like the big one.
Okay. Oh, this is the one with all the tables on it, yeah.
Matt doesn't need a formula sheet. Matt is the formula.
Gotcha.
Okay.
Sorry, I was
Okay.
that was creepy. Morgan, I think you made my day today by
her messing up.
I was extremely confused.
I know, you're about to give her the markers so she can go draw.
What would be good is if she went up and drew it. I've been like, yeah, that's right.
是 x square 什么 g o f，他刚说的，这还 p 也给了。
Is it just the chi minus test, or is it the chi GOF?
The GOF, this is called goodness of fit. The
Okay.
reason why we do it is we're comparing our observed to what was stated as true.
Okay.
Does that make
So
sense?
that's when you use the GOF.
Correct. So
Okay.
this right here is the GOF. When you go to the other tests, we have two other ones that use chi-squared, same idea. But when we compare like one to another,
Yeah.
like if I said this, like these M&Ms, the regular versus the peanut, and then we compare the distribution of those,
Okay.
that would be another chi-squared.
Okay.
But this is just comparing to what they say to be true.
Okay. Gotcha.
Again, just so y'all know, this is called the goodness of fit, chi-squared. Right there. Right. Yes, ma'am.
Alright, so our x squared is 9.2.
You can do draw. It's fine. You
Check
put in that one
conditions
L2.
random. I guess assume it's random, right? Put when one is selected.
So you can go back to stat. That's okay.
Selected.
You go
And
to
then it
your
says large count,
just
which
change it to
expected
L3.
count
The
is
expected.
lowest,
It's good. You what?
are all of the
Y'all good on this?
Yes. They all are good.
Someone?
And then which expected count
Did
is
y'all get? I
lowest.
want to make sure I did it right. Did you get 6.5 here?
Right, is that
Yeah.
easy to count?
And 7, 10, 8, 12 and 6.5? Did you get your chi-square value?
9.22.
9.22?
Yeah.
Perfect. Alright, I want to make sure you all at least get one rep in the calculator there. Make sure that you match up the values you see up here, okay?
Is that what our
Test the statistic for this test.
I don't know.
9.24它上面写的是。
All we found was chi spectrum. Is the chi the test interesting?
That's exactly right.
这个
So chi-squared is like the z-score and
Okay, that's
t-score.
what I thought.
Yeah, that's a good thought. So chi-squared is that value there. So if we were to draw it,
写的是 p 的。
like here, this chi-square value is 9.22.
Yeah.
So we're trying to find this area, which is our p-value.
Mm-hmm.
0.1是说
So you use the table C to find that.
Exactly. That's where we're going to use the table C. Cool.
That's
Or
our
you can
formula
use-
sheet, right? Table C.
Correct. Or you can use chi-squared CDF.
0.1和5是
You could use either of those two.
Okay.
Good point.
9.24不好意思，我不会说话。
就是 p。
这是
哦
错了。
Oh, maybe.
哦。
Oh, here it is.
提到了
So this is lower, upper, we know where lower, lower. I guess lower would be 9.22, right? What's above that WR? Okay. 9.22.
你还这个
Upper, like 9.9. Then 0.1.
I'll give you one more minute to kind of wrap up. I know some of you are still working, so keep it rolling.
还给了个
Oh, I was thinking 0. Okay, I got it. No, so we are. We have to accept it.
Based on 0.05.
Okay, you're right. Just check.
It's
So
similar.
we
Y'all are
make
gonna
conclusions, so we say that we answer that HO.
Did y'all do well on that chapter? Yeah, or biology.
It was just a group, like it was one little part of like one like artist wanted to be like.
So we accept expected
You have to write a lot.
How do I?
Not really. We didn't have
So
to.
she's
We just had
asking
to
us
fill out
if the
the bottom
distribution
chart.
is true, so we
We
accept
like fill out the
the
observed
given distribution
and then at the bottom we fill out the percentage. Yeah, that's it.
That's not bad. That's not bad. It takes, this just goes into more depth.
Yeah.
we accept the
Yeah.
Okay, y'all good?
然后给三个，但单个选了专业就被拒了。不能选，是因为人太多了，是录取了，是人太
Let me show you. Can I show it up here? Because I've got it up here. And how people to just kind of say, oh, this is how you do it. So we'll do that here in a second. Cool? That'd be good. That's a great question. Great question. All right, hey, do this just so we're all on the same page. I want to make sure everything is squared away. You're going to notice the same 4-step process is the same thing we'll do for chi-squared, okay? If you didn't hear me talk to James, section 11.1, both A, now we're talking part B, is talking about chi-squared goodness of fit, okay? There's a difference between chi-squared, GOF, or goodness of fit, and the other two, which we'll talk about in 11.2, okay? Did everyone get 9.22 as their chi-square value?
Yep.
No, you did not?
Did you get one?
Okay, perfect. Do this, Matthew, when you're done, just touch base with me, make sure that you got it, okay? Remember, too, there's 2 conditions that we have to check with chi-squared, all right? One is random condition, okay? And it was random because we randomly selected it, right? The second one is a little bit different. We have to show that every expected observation, or expected value, don't want to use observation, expected value is greater than or equal to 5, cool? If we show that, that takes care of the large counts, which what did we show normally for large counts earlier?
Should be greater than or equal to 10. Full.
Okay, n times p, okay, and yeah, it's greater than or equal to 30, right? Depending on whether we're talking about t or z, right? Or mean or proportion. So all expected counts have to be greater than or equal to 5, all right? Okay, good. Let's talk about this. For the test, D of f is the categories -1, right? So in this context, what's the DF or degree of freedom? 5, good. What is the test statistic for this test? We said 9.22. Now, the great question that people brought up, other than using your calculator, well, first off, let's do that. How can I use my calculator?
You use the x squared. So
What would be the first value?
it'd be the 9.22 and then just a big number.
Yep, and
5.
and then 5, which is degrees of freedom.
Yeah.
Cool.
Wait,
Now,
what was that gave you? Like, which is that the p-value
That's
then?
the
that gave you?
this would be the p-value that was given to us. So, Emily, if I was going backwards here, this highlighted area is how I would find the p-value by plugging that in. Cool? All right, very similar to normal CDF. Now, the one other thing that you can use is your table. And it's actually very important that you understand both, because a multiple choice could pull from either. So if you were to, let's say, go to, let's see if we can pull this up here, right here. Okay. So if you went down to your test statistic, so we have degrees of freedom of 5,
Yep.
and our test statistic was what?
9.22.
And degrees of freedom was, oh, wrong one. I was like, oh my gosh. Okay, here we go. 5 and 9.22. You'll notice that it's between what? Exactly, 0.15 to 0.10. It is not important for you to understand that it's an exact number. You would just simply say it's between 0.15 and 0.10. So you could say that. But if you use your calculator, you could get the exact p-value. What did you get for the exact p-value? 0.9?
Or 0.100.
5?
Yeah.
Perfect. And you could use that as well for your p-value, okay? D, did that make sense from what we were talking about? Perfect. So what can we make a conclusion about using our 0.05 sig level? James?
That we accept the given distribution based off P being greater than 0.05.
I like it. And just to keep it consistent, which is what you said, since our p-value is equal to 0.1005, and it is greater than our Jesus fish of 0.05, okay? We what?
We accept the given distribution, or we accept the.
We failed to reject HO. Okay? Now, what is HO again?
Yeah.
Perfect. That the claim is true, right? So we would just say we do not have convincing evidence to reject HO, which states, I know this is long, I just want to make sure we get it the cookie cutter way, which states what? The claim distribution of M&M colors is what? Colors is true. Good. Evan, we do not have convinced to reject, yep, which states the claim distribution of M&M colors is true. Good. Questions on this? B.
So in the real test, do we have to state like the HO and AJ for this type of question?
We will. And actually, we'll look at that here in a second. Great question. We'll look at how that flows out to a 4-step process. Good question there, okay? All right, we good? All right, could anyone give me an interpretation of our p-value? Tell you what right now, I got 3 tickets, someone who could tell me that.
Our p-value?
The p-value interpretation.
Oh, shoot.
I'll do it for your house.
My house? You can name my second child. Go.
Oh, go on. Oh.
Are you having a second child?
No, it's not official. Not official. No, we are not. Wait, that really got awkward. I'm sorry about that. I deserved it though, right, Corey? Maddie, go ahead.
Okay. The probability that the probability that we rejected HO was 0.1. Having purely by chance was 0.1005.
I like that. Can someone tweak it just a little bit? I like it. Matt?
So it's the p-value of 0.10 is the probability that our observed values of M&M distribution is that far from the true expected values. It's that far or greater, happening purely by chance.
That's it. That's fine. You could say either or. That's good. And I would say also, just to include on that, we assume what to be true.
Assuming the expected value.
Assuming HO is true, right? It is the probability that occurred, the observed value occurred purely by chance. You could say that, simplify it, put a little context in it, wrap it, and go. Cool? All right, questions on that? Are we good? Hey, this also has been brought up on an AP exam, so I just wanted to make sure. Which color M&M had an observed value the furthest from the expected?
Blue and green.
Yeah, let's make sure. I think it is.
Oh, no, it's just green, yeah.
Is it green?
Yeah.
Yeah, we would say that, and you would just say, and I want to make sure I put it here. Let's go back. I just want to make sure I put this down appropriately. So we would say that green, sorry, I'm a little tall here. Green was the higher or lower than expected?
It was lower by 6.
Was lower than expected, and I would even put by 6. Cool? And put that in there, okay? And by the way, I'm so tired. I did not miss Friday because it was Leprechaun Day. I've had a lot of people who have said this.
A leprechaun convention?
Yeah, it wasn't a Leprechaun. I was with my family, for crying out loud. So thank you, Matthew. I didn't help my cause.
You had to go find us a pot of Goldenberry last year. On the other side of the rainbow.
That's right.
Dig it up.
It's fine. I found the gold, so thank you. Okay. So here's the deal. Hey, we are going to put this in a 4-step process. We're going to do this quickly. You've already done all of the details out, but I want to flow this out. What would it look like on a 4-step problem on an AP exam? Okay? So real quick, I want to just put it out there. What's the null?
Claim is true.
Yep, we would say the claim color distribution is true. The claim color distribution is true. Okay, a lot of this stuff you already have down, but I just want to make sure you get it down in the process, okay? What's the alternative?
The claim is whack. It
I-
ain't true. Whack.
Please do that. I'm gonna make it. It is not true, okay? So I would just say the same thing. Claim color distribution is not true. Significance level is
0.05.
good. If it doesn't stay, what do we assume it?
It's 0.05.
0.05. Here's the kicker, kind of the side note. The test is a chi-square test for goodness of fit, okay? Thanks to Morgan, she helped us with understanding you could also put chi-squared, the symbol, too, okay? All right, is sufficient as well. I would also recommend that you, in this plane phase, you don't have to, you could put it in the do phase, but I would also make sure that you put that picture of a skewed right graph with your chi-squared value, which was 9.22 down below, and understand that that right there is our p-value. Notice again, it always is at 0 because this is always positive values, okay? So just remember that. What are the two conditions we need?
Random and large counts.
Random and large counts. Why do we use large counts, not normal?
Because the chi-squared isn't normal.
Correct, it's not a normal graph here, okay? Good. This would not, all we need are those two. Random, obviously it's stated. Remember with the large counts, how do we know something is large counts?
They're all greater than 5.
Yep, expected must be greater than or equal to 5. Okay? That's the thing there. And I would make a sentence about that, just like you did with random. Okay? All right, good. Questions on that? Cool. Go ahead, Ella.
Can you please go back?
Absolutely.
Okay.
My apology. So again, we check the conditions of random and large counts. Again, remember this is goodness of fit, okay? Section 11.1b, just a heads up on that. Okay? All right, are we good so far? Okay. All right, now we did the picture already. You could redraw the picture if you needed to. But we also really, this is the big part here. Once we put the picture here, what's the specific formula? You have to state this.
Is it the C?
Observe minus expected squared over
Good. And really, this is stuff you already know how to do. You can do this on the calculator to find our chi-square value. However, on the AP exam, they require you to at least show 1, and a lot of times they want 2. So what I mean by that is if we went into the one that we were stating here, which was, let's say the brown one was observed was 4, we would say the 4 minus 6.5 divided by 6.5, and then this is squared, right? We would then add, and this is how they want it. We'd put ... and then we could just simply put the last one there, okay? So the last one was the red, which would be 10 minus 6.5 squared divided by 6.5. And that right there, what would happen here is that just says that all the ones in between were added. That just shows work there. And then on the calculator, you could just say, okay, our chi-square value, when I take the sum of all of these values here, that is going to equal my chi-square value of 9.22. Okay? Does that make sense on what's expected?
Yep.
All right. I think, trying to make sure, so we did that, and I would even put, and just so you know, I might even put above it that this was the brown, this was the red, and then AP graders can kind of get everything in the middle, okay? We're just adding everything in the middle. Cool. So with the test statistic, we get 9.22. If we use our calculator, what else do we have to show?
We gotta get our x squared CDF to find our p-value.
And we have to establish, so what's the established part?
lower,
Lower bound,
upper,
upper
degree of freedom.
bound, and degrees of freedom. Okay? And what's degrees of freedom here?
5.
5.
Good, and it's categories minus 1,
Yeah.
which would be 6 minus 1, which is 5. Okay? I know this isn't the most exciting thing. I just want to make sure we get it. So I love it. I do love it. What's the p-value?
0.01005.
0.005. So we put down that p-value, and then Finally, when you go to the conclude phase, which would be below, you just simply put the conclusion that we already had stated earlier. Okay, Ella?
What is lower bound and upper?
Good question. May I go to the next back slide? So when you go to the lower bound, your lower bound would be your 9.22 chi-square value. And then what's cool about this is I've not seen, everything we're doing is on the tail. So you're going to look from 9.22 to the 99999, and then comma your degrees of freedom. That's there. Does that make sense? That's why we have to find the test statistic here.
Yeah.
Okay? All right. I think that's it through here. Conclude. Are we good on conclusion?
Yeah.
And again, I want to make sure. One other thing that I would say in the conclusion, was this statistically significant?
No.
No, because we failed to reject, right? So we failed to reject. It is not statistically significant. Just a heads up. Remember that. Okay. All right. So question: what parts of the usual 4-step process are missing in the chi-square test that we did on a lot of the other tests?
Independent, yep.
Independence. Good. Did we use independence? I don't think we did we? Yeah, the 10%. We didn't use 10%. Okay. We didn't use what else? Yeah, we really didn't have. CLT is more. It's got to be greater than or equal to 5, right? But it's not really normal, right? But it's assumed that it has to have large counts, right? So we'll leave that off. Do we have a parameter or a statistic?
I was going to say that.
No. There you go, James. No parameter or statistic.
Yep.
And there's one other thing.
We didn't have to describe our value.
Like greater than or equal to.
Maybe you could help me with this. I put down
Like
general formula. Do we have a general formula that we use?
Yeah.
Yeah.
There's like a specific one.
And what I mean by that is, like, we're not doing the statistic minus the parameter divided by our standard deviation, right? Just a little different on that. So we do not have that in that context, okay? All right, hey, we will go over some of these. Here's the deal. You have all of these already. As you leave, I'm going to, just on the podcast, fill in what the golden nuggets of today are. And that way tomorrow we'll start with the check your understanding, make sure we get it, okay? All right? Other than that, be blessed. Have a great day. You may, yes ma'am. Do you need my charger? Yes ma'am. I think that should fit. Yes ma'am. Yes ma'am. So I need to exchange that. I haven't done that. Chapter 10 is you've
Big
done
man
it,
with
right?
tickets.
So I need to get hired.
I could get less.
Huh?
So I'm gonna exchange that. I actually have a note down in my to do that.
It's always something on
To update that. So I will. So I appreciate that. Cool. Absolutely. I'd love to.
Bye.
Anything you need of me, I'll see y'all.
Actually, I don't have a block. Can I just charge it on my computer when I come here tomorrow?
That's fine if you want to right now. Do this. Charge it on this computer, my computer right here, if you want to, and I'll just leave it here when.
Okay.
Is that cool?
Yeah. Thank you.
Sorry, I forgot I didn't have it, but yes, I will. I'll definitely do that.
Here. Thank you.
My Yoda?
Yeah.
Am I really? Oh, great.
I fall asleep in your class.
What's that?
I fall asleep in your class.
Oh, I think that'd be
And
awesome.
then you wake me up.
Cool. I'm in. Just let me know when, okay?
Me, you, Trey, and Ken.
Bye. Thank you.
Cool. I'm good with that. Let me know and I'm 100% in.
What classes do you have? Do you have a first period class?
I do not.
Uh,
Cool. Just let me know what day works, okay? See you, Matthew. All right, hey, y'all, I apologize for that late podcast here. We're just going to fill in a couple things of the golden nuggets for the day, things that are important to remember, and things that we just want to make sure we hit on. Number one is just remember our conditions. The one thing I would remember with our conditions are there's two conditions that we need to know. One of which is large counts, which states that my expected values must be greater than or equal to 5, okay? So remember that. And then a lot of times here you'll show the lowest count. Whatever one was the lowest. The fact that the lowest was the greater than or equal to 5 tells me that all of them are greater than or equal to 5. So just a heads up there. Condition number 2 is that it's random. This is the same thing we've talked about before. If I've selected it at random, if it's an SRS, we're good there. And that's what we're expecting to show there. Number 2 is another one just to kind of make sure you touch base on. Remember that the chi-square distribution is a skewed right graph, okay? It's always skewed right. Also remember that in this context, we're talking only positive values, so we start at 0, and as we move to the right, we note that because of the fact that the formula is squared. Remember the sum is observed minus expected, but the squared always makes it positive there, and then we just divide it by our expected there. Oh yes, the chi-square is also related with degrees of freedom. To find my degrees of freedom, I simply go n minus 1, where n is the categories. That's important, okay? And it refers to the categories that are there. And that's number 2. And then finally, number 3, we want to make sure we hit on the last one. Again, we're looking at 4 steps with our state, plan, do, and conclude. Okay? So again, just a heads up on that. Make sure you do it. If it is significant, this is something too. If significant, make sure to address and discuss the largest one that's away from my observed value. So the largest, we call it the contributor to increasing chi-squared, okay? Again, I hope that helped with where we're headed. If you have any questions on that, please come by, touch base with me on this, but I wanted to make sure I give you the golden nuggets for the day. Hope all is well. Way to dominate. See y'all.